Welcome to the channel. In this video we are going to discuss system of circles important problems. In this, problem on the concept radical center. So how to find the radical center when the three circles are given. Here the three circles in the question, find the radical center of the following circles. The circles are x square plus y square plus 4x minus 7 is equal to 0. 2x square plus 2y square plus 3x plus 5y minus 9 is equal to 0. And x square plus y square plus y is equal to 0. So here, one more important thing you have to remember that whenever you are finding the radical center, so what we know that we have to find the radical axis of any two set of circles. So now here, so in these three circles are also, one more thing you have to observe that the three circles are in the general equation of the, in the form of general equation of the circle or not. So here, if you see that the first circle here, so let S is equal to x square plus y square plus 4x minus 7 which is equal to 0. So you say this is circle 1. The second circle, suppose if you see that, so here S dash is equal to, we have 2x square plus 2y square, so plus 3x plus 5y minus 9 is equal to 0. And here it is not in the form of general equation of the circle. General equation of the, in the form of general equation of the circle means the circle must be in the form of x square plus y square plus 2gx plus 2fy plus c is equal to 0. But here this is like 2x square plus 2y square plus 3x plus 5y minus 9 is equal to 0. So that's why first you have to transform, that means divide this equation by 2, then we get x square plus y square, so plus 3 by 2 into x and plus 5 by 2 into y minus 9 by 2 which is equal to 0. You say this is second equation of the circle. Now this is S dash here. So S dash is equal to, that implies S dash is equal to this is. So the given equation is not in the form of general equation. So that's why we transformed that equation in the form of general equation of the circle. So then the third circle is given here. S double dash is equal to x square plus y square. So plus y is equal to 0. This is the third circle. See, observe here, we have the three circles like this. So those three circles centers are non-collinear. See, like the centers of the circles are there. This is S is equal to 0. This is S dash is equal to 0. This is S double dash is equal to 0. Like this, the three circles are there. Here we can say that, so this is the radical axis of circles 1 and 2 here. So, and here the radical axis of circles, so 2 and 3 here. And this is the radical axis of circles, so 1 and 3. This is circle 1 and this is circle 2 and this is circle 3. So after finding the radical axis of three circles here, so now this is the, so fourth equation, suppose radical axis. So either this is fifth equation or you can take sixth equation, this is. So that means you have to find the radical axis of any two set of circles. Now what I am doing is here, finding the radical axis of 1 and 2 circles. Now I am finding here, therefore the radical axis of 1 and 2. The radical axis of 1 and 2 is, so here S minus S dash is equal to 0. The radical axis of 1 and 2 is here, S minus S dash is equal to 0. So now what is here S? This implies that S is, so x square plus y square, so plus 4x, so minus 7 and minus of the second circle is here x square plus y square. So plus 3 by 2 into x plus 5 by 2 into y minus 9 by 2 is equal to 0. Now, so here this circle equation, if you multiply with minus, then we get x square plus y square. So plus 4x minus 7 and minus x square minus y square minus 3 by 2 into x and minus 5 by 2 into y and plus 9 by 2 is equal to 0. Now if you observe here, the terms x square and y square all gets cancelled. Here 4x minus 7 and here minus 3 by 2 into x minus 5 by 2 into y plus 9 by 2 is equal to 0. When you take the 2 as LCM, here this is 8x minus 14 and minus 3x and minus 5y, so plus 9 whole divided by 2, which is equal to 0. Finally, if you simplify, we get 8x minus 3x is 5x, and here, so minus 5y, and here minus 14 plus 9, which is minus 5, which is equal to 0. Further, you can write this is also implies if you cancel this is the equation with 5, then you can reduce it. X minus y minus 1 is equal to 0. So you say this is a fourth equation. This is the fourth equation. So now what I am doing is here, so to get easily the radical axis of that means I am finding the 1 and 3 circles. Why? Because here circle 1 and 3, from that also you can find the radical axis. So that's why I am finding here the radical axis of 1 and 3. 1 and 3 is we have, so 1 is S and 3 is S double dash. So that's why S minus S double dash is equal to 0. S minus S double dash is equal to 0. So we get here S is the equation x square plus y square plus 4x minus 7, and here minus of the third equation is we have only x square plus y square, so plus y, which is equal to 0. Then further it becomes, so x square and y square terms are gets cancelled here. So this is x square plus y square. So here plus 4x and minus 7 minus x square minus y square and minus y, which is equal to 0. So here x square and y square terms are gets cancelled. We have here clearly, so this implies 4x minus y minus 7 is equal to 0. 4x minus y minus 7 is equal to 0. If you say this is fifth equation, now see here the radical center here, the point of concurrence of radical axis is called the radical center. So that's why all the radical axes are passing through the same point. Now to find this radical center here, so we can solve the equations 4 and 5. Solving the 4 and 5, the point of intersection of 4 and 5 is only the radical center of the given three non-collinear, whose centers are non-collinear. So that's why solving 4 and 5 here. So x, y, 1 by the cross multiplication method. So here minus 1 and minus 1 here and 1. So here minus 1. So middle, right, left and again middle. So minus 1 and 1 here and again minus 1. Again here we have, so middle is minus 1, minus 7, and here left is 4 and middle is again minus 1. See, when you have to find the value of x is equal to these two, you have to multiply. So this is minus 7 into minus 1 that is 7, and minus 1 into minus 1 that is plus 1. So but here minus 1 whole divided by minus of plus 1. So here this is 1 into minus 1, so which is minus 1, and here minus 1, so into 4, so that is minus 4. Actually minus is there, here plus 4. So this is 6 by 3, so we get 2 here. X is equal to 2. So now similarly to get the y value, so these two if you multiply, so this is minus 4 and plus 7 whole divided by, again this is minus 1 plus 4, so which is equal to, this is 3 by 3, which is equal to 1. See the point of intersection of 4 and 5 or 4 and 6 or 5 and 6, any two sets of radical axis is the radical point of intersection of any two set of radical axis is called the radical center. So I have taken for our convenience here to find the radical axis. So I consider the first 1 and 2 equations of the circles, and for our convenience again I consider that to find the radical axis here. First and third equations I considered here. So I get the radical axis are like this: x minus y minus 1 is equal to 0, and 4x minus y minus 7 is equal to 0. Point of intersection of these two, that means 4 and 5 radical axis, is the radical center. So therefore finally we can write the required radical center. So which is equal to, that is x comma y, so which is equal to, so 2 1, so which is the required radical center.